All right, now we're going to talk about translation. Translation occurs after transcription. So, a real quick recap on transcription. Transcription occurred inside of the nucleus. It was a copying of a segment of DNA called a gene, which encodes the instructions for a particular protein, into a mRNA strand right here, messenger RNA. So again, messenger RNA is much shorter than a DNA strand because it's the instructions of just one protein, and DNA strand can contain the instructions of many proteins. So we only want to build this one protein. So transcription has occurred, mRNA strand has been made. Now the mRNA strand will leave the nucleus, go to the cytoplasm, and find a ribosome. The ribosomes build the proteins. So that's what we're going to show now. So our mRNA strand will enter the ribosome. The ribosome will read it, and we have these three sites here, E, P, and A. P is where the amino acid will be dropped off. A is where the next amino acid coming in will connect, and E is our exit site. So after a tRNA has delivered its amino acid, it'll move to the E site, it'll disconnect and go pick up some more amino acids. So let's see here. How do we read this? Well, again, ribosome reads it a codon at a time, or 3 nucleotides at a time. A, U, G. Now what does that mean? Well, there's 2 ways that we can figure it out. We can use the genetic codon chart, or we can use the genetic codon circle. Either one will get you to the same place. Let's take a look at the circle here. You start in the middle and you work your way out. Now again, I was A, U, G. A, U, and then I find G. MET, methionine. That's the amino acid that AUG, the codon, coded for. Using the chart, I would start on the side, A, go to the top, U, and then go to the opposite side, G. So I'm in this row, and then I was in this column, and now that I'm in this box, I look for the G. There it is, AUG, methionine. So either way, works, whatever you're comfortable with, go for it. So let's find that tRNA molecule with the methionine amino acid attached to it. Here it is. Now, this is our start codon, AUG. AUG is the universal start codon. So this tells the ribosome that you're going to begin translating at this point right here. So we're going to come in and we're going to connect the codons of AUG, the nucleotides AUG, this codon here, with the anticodon of tRNA. So you have codons on messenger RNA, and you have anticodons on tRNA. A with U with A, G with C. Because again, it's RNA. There is no thymine. And attached, we have our amino acid. Now let's take a look at the next one. UGU. I'm going to get my circle. UGU. CYS. Cysteine. So I'm going to go ahead and find it. Here it comes. And it's connected. So we're going to move in, and as we move across, we're going to keep reading because we're going to keep going. We're going to get these 2 amino acids to bond with each other. To do that, it'll disconnect from this tRNA molecule as this one moves into the E site where it will exit, and it will bond. Now the bond that is occurring here is a peptide bond. What we are creating is a polypeptide. The polypeptide will eventually become our protein. Now our next amino acid to come in, GAG. I'll look at my genetic codon circle. GAG. And here we go, GLU, glutamic acid. And again, we move along through our ribosome. This tRNA molecule will disconnect, and we'll go find some more amino acids to be used again. Another peptide bond will be created, and we will move our way along. And we repeat this process over and over again, and we would create a polypeptide. Now I'm going to pause the video for a second. I'm going to put this together and show you what a final product looks like. Okay, we're back. We have a long chain here, a polypeptide chain. We're on our last codon, UAG. So let's see what matches up with UAG. U, A, G, stop. I need to find my stop tRNA. There we go. So UAG was going to code for stop. And there are several other ways to code for stop as well too. There's only one way to code for start, and that's the AUG. So as this moves along, disconnects, our tRNA molecules, they leave. Our mRNA leaves the ribosome. Now we have ourselves a polypeptide chain. Now this polypeptide chain can then be formed. It can be formed into a three-dimensional shape, and that shape will help it determine its function as a protein. Shape determines its function as a protein. So hopefully this overview of translation has helped. If you have any questions, please leave them in the comment section below this video.